Hey everybody, we are taking notes today. If you were not here to make the notes, you need to take these notes and make sure that you illustrate them, draw them, and write them down to explain how simple machines work and how they make jobs easier for us. So without further ado, just so you know, it's right here. I'll have a video here just to help you out. Present. Start with first simple machine that we're going to talk about is a lever. Now, the kind of lever we're talking about is a first class lever. A first class lever is basically got this fulcrum, which is the center point where it pivots around. Either end, one end is the effort, the other end is the load. It's a teeter-totter, basically. Now, class 1 lever, fulcrum, that's the pivot. You've got to be able to understand and label what these things are. The input is the effort on the device, and it's on the one end of the fulcrum of the lever, and the other end is the load. And the output on this case is the load, and that is a class 1 lever. Teeter-totter is a classic example. Now, if you move the effort away from the fulcrum, it gets easier. If you move the load towards the fulcrum, it gets easier. Think of the big person and the little person on a teeter-totter. These help us do a lot of different jobs. So the load goes in, makes the job easier. Levers. This is a second class lever. You've got the fulcrum on the right. You got the effort on the left. You have the load in between. Fulcrum, effort is the input, and you lift up on the input of this one. And the output is the load, which is in between the two. Class 2 lever, fulcrum to the right, effort to the left. If you move the load inward, it gets easier. If you move the effort outward, it gets easier. And that is the second class lever. A door is where you might see that. That's a pretty common second class lever. Now, third class levers. Third class lever has a fulcrum on the right, the effort in between, and the load on the left. Third class, fulcrum on the right, effort right of the load and left of the fulcrum, so it's in between the two. This one is classically used on cranes. Doesn't make the job that much easier, but it definitely makes the work better. So if I move my effort inward, it gets easier, and the load outward, it gets easier. Okay, you got to change those arrows. Inclined planes. Inclined planes we use all the time in all sorts of different situations. Think of pushing up a ramp. The longer the ramp is and the less height that you have, the easier it is. Longer is better. Height shorter is better. And here's a classic example, loading dock of a truck. And another one is this truck. Now this isn't a great one because the truck should have a longer ramp on it and it would work better. You can see the ramp's kind of short on this one. A wedge is a fancy form of inclined plane, except for the thing is it's pushing two things apart. The longer it is, the better. The narrower it is, the better. The narrow is called the taper of the wedge. Shorter is better. Twin-sided tapers are better than one-sided tapers. So this is a twin-sided taper. So it effectively cuts the taper in half. Here's an example, a knife. Now, in this case, let's move the blade. This one is a twin-sided taper, so that's the better of the two, of the three here. This is a one-sided, this is a one-sided, this is the better one of the three. Here are classic wedges. Now this circular one isn't as good as this flat one because it's going to distribute the weight, the push along a longer area, and that gives you more leverage. Now, the next tool we're going to talk about is a wheel and an axle. The smaller the axle, the better. The bigger the wheel, the better. Axle's internal shaft is rotated around. Smaller is better. Wheel, bigger is better. Now, the one you're going to see here is a little different. You usually think of it as a wheel and axle, but it's totally a wheel and axle. And this is like a well crank. So the axle's in the center. You got a handle outside. That acts as your wheel. And you end up, the longer the handle, the better. The skinnier the axle, the better. Now, a fancy form of wheel and axle is pulleys. Now, pulleys magnify forces because you start adding wheels and you start adding forces. Same thing, wheel bigger, better. Axle smaller, better. More wheels, better. There's actually mathematical formulas that calculate all these. This one's 1-to-1. This is 2-to-1. This one's like 4-to-1, and this is like 5-to-1. The thing is the rope needs to be much longer if you start pulling on these two. Screw. This is one that you see a lot, and you don't even think that it's a screw. But screws move things very short distances, but very forcefully. The bigger the diameter of the screw, the better. The smaller the pitch or the angle of the screw drive, the better. You move things slowly with those. This is what my wife's insulin pump uses. And an insulin pump pumps little bitty amounts of insulin into her body all the time, so her blood sugar tries to stay normal. Short distances, very heavy things can be lifted, like cars. One of the most common uses of screw in industry is a screw jack, and we'll see one of those in just a minute. Diameter, bigger is better. Now, here's a screw jack. And you can lift up cars with these very easily. And I believe that's all of them. All right. Well, thank you for listening, and make sure you get those notes.